So let's start. We're going to talk about Dockerfile directive. This Dockerfile directive standard which are given to us by Docker. This is not something we can create on our own. There are certain standard keywords or standard directives given by Docker as a content solution, and we have to use them when we create our Dockerfile in order to create images. The first and the most common and widely used is from. So when I say from, so what does from means? Let's say I want to pull some image from some Docker hub or somewhere locally in your machine image. For that, we use a from directive. Second one is env, that is environment. Now let's say Vaishnav wants to pass some password inside the image. Now we don't know what password to give, right? At that point, I'm not sure what password to give. If someone runs in container, at that time he can pass that environment value. In such case, we use env as the runtime variable. I'll show you with an example how that is done. Runtime variables are very important in certain scenarios. If you want to pass passwords, username, certain values of any choice, for that scenario we use env. Same way here in Docker Hub, we use this env command, or you can say this env directive, to set up the environment variable. The next one is run. To execute any command in the Docker file, we use run basically. The next one directive is cmd. So I think cmd, what should be run at run when we launch a container, that what is specified in cmd. Next Dockerfile directive expose. So what port number we need to use internally, internal to our image, to expose our application. That is what we do using expose. Next one is working directory. So let's say inside the image, I want to run a command. So I need to define from where should I run. So for example, using working directory or work dir, we define which particular relative path or which particular directory location we want to execute that particular command. Copy command, I think copy command as a name implies, if you want to copy any file or anything from your local machine to the image, we use copy or vice versa. So copy can be used to copy the content from your local to the image, or from a running container to your local machine also. That is another important directive called copy. Add is similar to copy but more powerful. So difference between add and copy does the job as it is, but add actually copies the contents. It don't copy the actual files. If I use a command add some tar file to some location, it will just copy the contents of the tar file. It will not copy the tar file, because tar files are very bulky. They make your image super huge in size. But comparatively, what will copy command do? It will just copy the entire tar file. Then you have to add another step to unzip the tar file, and then once the contents are copied, then remove the tar file. But add is a very advanced command. If you want to download data from some web URL like GitHub, or let's say some path over the internet, then we use add command for it. Stop signal. So if you play with, let's say, Linux kernel, we would have used some commands like, let's say, kill term or sick term. So basically we are telling to stop the container or kill the container. So when we run the command docker stop, what we are giving it, we are telling the container what type of stop signal we want to pass to it. The default stop signal defined by Docker community is sick term. That means signal terminate. Using a stop signal command, you can override that and define what type of stop signal you want to specify for your scenario. It can be anything. It can be like sick term, sick kill, sick stop. Sick stands for signal followed by what you want to do. The default is sick term, signal terminate. So when I do a docker stop command execution, what it is doing is it's doing a signal terminate. That means it is telling the Docker engine to terminate this particular container. That is what this command stop signal does. Now, next one, and the most important, health check. How will you make sure a container is healthy? So health check is one such command which can help us to check the health of our container. Now, what is the beauty of health check? When I give a health check command in my Docker file, I can give my own customized string to check health. So for example, let's say Parikshit wants the criteria for his container to be healthy or not is if it is able to ping a local machine, say for scenario. So he can define in that health check string what is the condition which defines container is healthy or not. It is purely customizable. We can define our own customized string when we want to create our health check. So health check is a very important standard. So in enterprise, whenever you try to create a container, you try to define a health check for it, because using health check, you can make sure whether your container is healthy or not. We'll see right now in couple of examples how to use all these commands. We are going to see some advanced example of creating Dockerfile, how to use health check when I'm trying to create a Docker file. Same time, I'm going to pass some environment variable and see how that works up. So now let's go step by step and try to understand what different we are doing with Dockerfile from the scenario we discussed. First thing, from. Your from always need to be the first statement of your Dockerfile. Now I'm downloading an image Ubuntu. It's flavor Bionic version. If you want to give Ubuntu latest or just Ubuntu, that will also work. Then I'm defining an environment variable named trainer, and I'm passing the environment variable name as Kush. Did you see that? The environment variable name is trainer and the variable value is Kush here. That is how we are defining a variable using the env field. Simple as that. Then next we are doing a run command. We are updating our local repository, or you can download our manager apt-get update, and then we are installing curl. Same time we are installing nginx in the next command. Then I'm using a command called working directory. I want to define in which particular path reference or directory location I want to copy or make some changes to. So I'm defining my working directory as var www.html. Then I'm using a command add, and I want to copy this index.html file inside this working directory, that is /. Then I'm using a command called expose. So basically internally I want to expose the port of my application on port 80 inside my image. For that I'm using keyword expose. Then I'm using command cmd. Basically cmd is the command we have run a stop signal. So I told you, like, it is like a Linux kernel stop signal. When we say docker stop, it is passing this stop signal only. Here we are using the default value signal terminate or sigterm. This is a default value that is used when we pass docker stop. Even if you don't define stop signal, you just run a command docker stop. The default stop signal it takes is sigterm. When we run a docker stop, by default, what stop signal is passed? It is a sigterm, signal terminate. And then last, I'm using health check. So what is my health check doing? It is running the command curl localhost 80. So if I want to validate, I am getting data or response from any website or any internet site, something like, or let's say I want to transfer data to or from server. For that we use curl. If I do curl google.com, I will see response from google.com. So whenever you want to see some content of your site locally in a Linux machine, use curl command. You want to ping a website, simple as that. That is curl command, basically to validate the connectivity. Okay, this is the file we just now saved. We have index.html in this path. Let's validate if we have index.html. Let's build it. How to build again? Docker build -t. Give some name. So let me give the name kush colon, let's say a1, anything, and dot input path because in the location. Press enter. Let's do Docker images. So see, my Docker image is created. Docker images. So now my image got created, kush a1, which is 165 megabytes in size. Now let's convert this image into a container. So docker run -itd, and my image name, let's do port forwarding also -p, and then kush colon a1. If I do docker ps, what do you see in the status? Health starting. Up 3 seconds, health starting. It takes roughly 30 seconds to get the exact health of your container. So now keep on docker ps, just wait 30 seconds around. It will then refresh and show the actual state. See what is my health coming now. Let me reduce the size of this particular thing. See, it is showing as healthy. That means my container is healthy now. Did you see this thing? Were we seeing this in the normal scenario? No. So health check is a very useful parameter. The best part of it is you can pass your own custom string to define whether your container is healthy or not, which is not possible in most of the scenarios. Let's do one thing. Let's go inside this container which just now we created. So docker exe-it. If you want, you can give -it, or if you want, don't give, it's fine. Container ID and bash. Now if you remember, we defined one environment variable also, right? So if I do echo $trainer, I think that is the environment variable defined. You see its value is getting printed. Let me open the Docker file again. That way you can again see it. See here, I defined here environment variable trainer and the value is push. So when I go inside the container and I do echo $trainer, it is printing this value. That is how we can call the environment variable inside the this thing. Same way, if you want password, you can pass password also. There are multiple ways you can pass password. You can refer to some file path when you want to pass some variable here. That way that file will be called if you don't want this password to be visible to everyone. Let's build it into an image. So docker build -t. Let's give some name, push a2, and then dot. So if I do docker images, an image should be created. Now let's convert this image into a container. So docker run -d uppercase p, and then my image name push colon it. Now let's run the command docker ps. So a container got created and its health is coming as health starting. Now let's refresh it. Still showing health starting. It is showing unhealthy this here health check. Why it is showing unhealthy health check state? What I have done is to validate my system is healthy or not, it is looking for system status.txt file. So inside the container, I've defined some location, localhost default location of Nginx, and inside that looking for a file called system status.txt. If that file is present, then it will say status is healthy. If that file is not present, it is going to say status is unhealthy. As far I remember, in the current logic I gave, I nowhere put a logic to create this file called system status.txt. We did not given any logic to make this thing as healthy. So how to then do that? Because that is a problem now. So let's see how we can create this file. I think it's very simple to create a file here. There's nothing as such. Well, what we'll do here is we'll use docker exec. We'll try to create the file in this location. Container ID, whatever the container ID is. And now we need to create file in this location, localhost system status.txt. That is the location I define. I want my status file to be created or to be present. So I will put some string value and define this path where I want this to be created. And then this particular scenario. So what I'm doing is I'm doing docker exe echo OK and then create this thing in this particular location usr share nginx html system status.txt. So now if I do docker ps, it should show as healthy. Okay, just give it for 30 seconds. The status should get changed now. See here now. So what we just did, we just tried to create that file system in that location because that was the condition we gave to validate whether my file system is present or not. You no need to give sh-c, that is not needed. I just tried because I gave a syntax error there. So that is how we check the health status. Let's see cmd and ENTRYPOINT in real-time scenario. So let me remove this Docker file. So let's get a simple image from Dockerfile. Let's say from Debian OS. Use whatever you want. I define a simple command cmd bin ping. Okay, let's say I want to ping my localhost. So simple bin ping localhost. So whenever I create a container with this, it will run and ping my localhost to see if it is up or not. This is simple cmd I've defined here. So let me now just save it. Let's convert this to an image. So docker build -t. Let's give the name cmd1, whatever you want you can give, and dot. So now if I do docker images, I have my image created cmd1. Now let's run a container in foreground mode only. So docker run cmd1. Okay, simple as that. So see, it is simply pinging my local machine. Now just the container I built, it is simply pinging my container. Now docker run cmd1, I just gave a command echo push. Let's say for example, what do you think will happen when I run this command? Echo override. So now let's see it. I run this command, some container would have been created, but it just print the push value. Let's see whether container got created or not. I run a command docker ps. I don't see a container which is running and using the image called cmd1. If I use the command docker ps -a, I can see container got created, but what the difference you see? It is using the command echo push. It is not using the default command that we gave while creating the image. While creating the image, we gave the command as bing ping localhost. But while running this command, when I gave some extra attribute, it took that attribute as the command. It did not took the default attribute we specify. What I'm trying to say is using CMD, the biggest problem is you can easily overwrite the values or the command that you have given inside the image when passing in the runtime argument. That is a big flaw with CMD. Now suppose tomorrow, for example, I joined a company and I don't know what is Docker run with CMD, and mistakenly after Docker run CMD, I type something. Then what will happen is it will break the entire scenario. So CMD has got this security breach, I will say, that you can override this value while we are running any container. Let's edit the same Docker file, why to create a new one, and let's use ENTRYPOINT here. Directives are always in uppercase. Another point to note, okay? So don't specify directives in lowercase. I'm replacing CMD with ENTRYPOINT. Let's save this. Let's build this into an image. So docker build -t, give some name, let's say ENTRYPOINT1, whatever you want, and dot. So now let's first validate the basic job is being done or not. So docker run entry point one. Okay, I'm just trying to run that image just now I created. Expected, it is pinging the localhost, right? Same thing what we expected, it is happening, the first very basic command. Now same thing I will do again, docker run entry point one echo push. Now again I'm going to do docker run entry point one and echo push. Let's see what happens. Ping push name on service not known. First notice this error. Same time if I do docker ps-a, what do I see? It create a container, but it is still using the default command. It did not change the command, although I passed a runtime argument while creating a container. So using entry point, the first thing is your default value cannot be overwritten. Any extra variables we give, it will think as inputs for that particular command. So in my scenario, what we are doing is we are pinging, and the input for the ping is localhost. So when I run this command, docker run ep1 echo push, what it is thinking is this echo push is the input variable for bin ping. This is the beauty of entry point. So let me now run this docker run, let's say google.com, www.google.com. So if I do control C here, you see it is now trying to establish connection to the Google. That is the beauty of using this entry point. You cannot override the command value, or you cannot override the value of entry point while running or passing in the runtime argument. When you work in real-time scenario, you try to use entry point as much as possible. CMD problem is the CMD value can be overwritten at the runtime argument. So we saw all the possible options with CMD and entry point. So next topic which I want to focus on, multi-stage builds. When we create these images, how bulky are these images? 500 MBs. What is multi-stage build? Saurabh wants to build an application. Let's say he wants to build an application on Go language, Golang, okay? So what are the first thing he will need? It will first need an operating system, then Go language, the Golang that we call as. Then he will need a compiler. He will need some library, and what he will use Eclipse to prepare the code, right? If I want to compile the code, prepare the code, I'm going to use Eclipse to prepare the code, and then finally I will get my .war file. In my production machine, do I need to have Eclipse, or can I run my production machine just with the war file and the Golang environment? In the prod machine where I am going to run this, do I need to have Eclipse there, or can I just have a war file and the Golang runtime environment and execute the code with the war file, right? Now take the same example in terms of an image. Whenever we create an image, we define a lot of things which are mainly used to first compile the code, and then we try to run that image using some CMD or some entry point. Because of these things, what happens is image size becomes too long. So whenever we create a file in image, or when we create a container or image, whatever word, we always have two stages. First, where we prepare, we define the directive like apt get installed, apt get do so and so, run so and so. And second, we run the application. These are always the two stages which we have in any application. Using this multi-stage build, what we do is we try to make sure that our image size is as small as possible. We don't want our image size to grow exponentially, as we have seen, like image size almost half gigabytes, 200 gigabytes. So multi-stage build is an approach which helps us to restrict an image size. So now let's see, we'll take two scenarios. First, without using multi-stage build approach, and the same code using multi-stage approach build, how it impacts the image size. It's a very powerful command, docker system prune. Don't run it until unless you're very sure. It will just clean so much space. Okay, see what all it does. It removes all the stop containers. It removes any volume. It removes all the dangling images. So nothing it removed as such. So we do no image got deleted, unfortunately. So still I have the same level of images and docker ps, lots of running containers. But now no stop container. It would have removed all the stop containers. So let's clear it. ls-lrt. Let me remove this docker file. So vi docker file. To save the time, I will just copy the code. Okay. Because if I write the code, we're spending more time. So now what we are doing in this scenario, we are using Go language, okay? Golang. So when you download Golang, by default, it downloads the Debian operating system. We are defining the work directory as hello world. In case the directory is not present, it will create this directory in this slash location inside my Docker container. Then I'm copying hello world.go from my current location inside this directory structure, hello world. I am running some Golang command to create a compiler, or basically to create a compile file with the name hello world. And then using CMD, I am running that hello world file. Simple Docker file. Let me just save it. Same time, let me create a file called helloworld.go, since we need that, helloworld.go, and let me add some content to it. Okay, so I just added some content to this hello world.file to print a function hello world. Let me save this. So cat Dockerfile, let's validate, we give the correct name, hello world.go. Okay, so now let's convert this particular Docker file into an image. So how to create it? Simple as that. So docker build -t, let's give it as name as inefficient, for example, and then dot. So now it got generated. If I run the command docker images, how much size do you see of this image? Almost close to a gigabyte, right? 784 megabyte. It's a huge image. So if I run the command now, docker system df, you see my images are only taking some 2.28 GB of space. It's too much. Does it serving the purpose of creating a containers? No, right? What is the first selling point of containers across the globe? They are lightweight. 784 is like an OVA file size. If I create a VM and ship a package using an OVA file, it will almost be as the same size as this. How do I fix this problem? Now think technically. So what we did in this particular scenario, we first downloaded Golang. Okay, when I download Golang, it comes the compiler, the interpreter, the base code. Probably all those things I don't need for my prod environment. I don't need the compiler to present in the prod environment the image. I don't need that the interpreter present with it. I just need the hello world file be created and that file get executed. All this compiler code, interpreter code, packager code, which comes by default in your OS, it's going to make it very huge in size. If I replace Golang with Java and do the same scenario again with Java, all these things will come with the programming language. A compiler, its interpreter, its binary, its source code. I don't need all these things. For my image, I just want that particular hello world file. That is my end goal. I don't want to have my image size 784 MB. Who in the world need that? So in order to make it efficient, now I'm going to repurpose this code into two steps. In the first stage, I will show you how to prepare this particular file, this hello world file or whatever name you want. Second stage, we'll put a code that how to run this particular file that we have prepared. So that way it will not use any of the things that we have done in the first stage. That means using compiled or packaged source code that will not be referenced. Only the file that we prepared in the first stage that will be used in the second stage, and using that we can make our applications as light. When we cook food, okay, let's say whenever I cook my own food, I use lot of ingredients, right? So for example, if I prepare some curry, I'll use lot of ingredients, tomatoes, onions, potatoes, some tofu, some paneer, some spices, some milk, right? If I combine all the individual weight of these things, they are quite bulky. But when I get the final product, it's comparatively lesser in weight. So take this way, all those ingredients forms your stage one that I just now talked about, the prepare stage. Your stage two is the final stage, or you can say the final product that we call as run an application stage. So now the same thing which I just discussed, I'm going to show you in this two split approach. So now let's see how we can do that. So let me remove this Docker file, rm-rf Docker file, ls-lrt vi Docker file. I'll copy the code to save some time. So as I mentioned a while back, in multi-stage build, we split our code into two stages. First prepare, second run the application. Now, what is my end goal? I just need to run this hello world file, which I get from this Golang application. So what I'm doing in this first stage, I am using this Golang 1.12 version, and I gave a name as compiler. You can give whatever name you want. Don't think compiler means the typical compiler. You can give as Saurabh, as Ram Mohan, as Kush, anything that you want. Then I defined working directory as hello world, some common Docker directives. Then I copied that hello world.go file from my VM into this particular thing. And then I executed this command, the same command which we did in the previous Docker file. Now what will happen is this particular command, what it is doing, it is helping us to prepare or to get this file hello world, which we need to execute in the second scenario. Now this particular first thing is doing all the heavy lifting. When I say heavy lifting, doing the compiling the code or doing this thing, that's all is being done in this particular first stage. Now what I'm doing in the second stage, in the same Docker file, I'm using two from. So in the first from, I did all the heavy lifting and created that hello world file executable, prepared it. In the second part where I'm running an application, I'm using this Alpine operating system. I'm no more concerned about Golang. That is just the first stage. I'm defining the working directory root and I'm just copying from compiler. I just named it as compiler. So from this compiler, I'm copying this hello world, this file inside this root directory, and then I'm executing this hello world. Now, what is going to happen whenever we use a multi-stage build approach? It don't saves or it don't record the data of the first stage scenario. That is what we call as preparation. It will only take the size or the contents of the second step. That is how using multi-stage builds we can keep our images lightweight. Let's see this in real time. So let me save this and let me do docker build -t. Let's give name efficient, for example, and dot something. They changed this something. So now I'm giving 0, so that should work now, hopefully. Now it's working. Let's use the image docker images. So what I'm going to do here is I'll just use the default version of Golang now. Since my base OS CentOS, it is not working. I need to create a new VM where I can create a base OS as Ubuntu or probably RHEL 7. So next topic, what I'm going to cover is called as Docker volume. Let's take a scenario. So let's say Amrish spin up a Tomcat container. So now the that container is running some process and writing some logs. Now let's say tomorrow something happens to that container which Amrish created. He is not able to access the container. It is not being able to start. So what does Amrish need to do? He need to force kill that container and delete the container. Now what will happen is when I force kill the container and delete the container, then all the data inside my container will be lost. So because everything I'm creating is in containers, and we know containers are temporary in nature, we cannot save them. So when I force kill or delete a container, then all my data with that container will get lost. That is a very bad business scenario. Now let's say Sid is running his .com application as a container. Now when .com application is being running, a lot of logs are getting generated, a lot of customer transactions, which are being stored in some file inside the container. So now how does Sid takes care of backup of those files? Because if tomorrow, let's say I work with Sid in his team and I don't know it's an important container which Sid created, I just stops the container and mistakenly removes it also, then all the data is lost. So Sid may be collecting some very useful metrics or very useful data, but now that cannot be retrieved because I accidentally deleted the container or I accidentally stopped the container. That's a big problem. How do I overcome such scenario? Now take another scenario. I have got, let's say, 2-3 environments in my industry. Let's say QA, dev, prod. Say this is QA1, this is a dev one, and this is a prod one. I'm running an application, let's say an application which connects to database. Now the password, I've designed that application as a container, but the password that I need to connect database is different for QA environment, different for dev, and different for prod. Do I need to create 3 different images since my environment value is different in all the 3 scenarios, or I can create one image, one particular image, and pass some parameters which can be used in all the 3 scenarios. So you no need to create 3 parallel images. That is not the concept of Docker world. When we use Docker, we can use the same image across all the environment. But how do I see different container? So while running these containers, we can specify specific data during the runtime. So when I'm converting that image to container, I can specify the specific data for that specific environment. All these problems are solved using one very beautiful concept in Docker called volumes. So what does volumes help us? Volumes basically helps us with 2 fundamental things in container world. It helps to save data of the container, the first thing. And second thing, it helps to share the data of the container even if the container is lost or is not working. So it helps in 2 things, sharing the data, and second thing, saving the data. These are the 2 things which volumes helps us with. So very important concept, and now we are going to see how to play with volumes in the Docker. First, let's see how to create a volume. To create the volume, the command is docker volume create and give some volume. You can give any name of your choice, like say volume 1, for example. So now my volume 1 created. In what location or directory structures are volume created in Docker Hub? So if you go in this default directory structure, that is var lib docker, here if you go inside volumes, you see this volume 1 directory structure got created. That is how is the default directory structure where volumes gets created. So now let's go inside the cd underscore data and let me create some files here. Let's say touch 1 2 3 4 5 6 7 8 9. I created some file systems inside this slash data which is part of volume 1 which I just now created. Now let's create a container and let's see how to do a volume mapping while creating a container. So Docker run, let's create a container in detach mode. Let's do some port forwarding. If you want to do a volume mapping, you specify -v. Dash lowercase v is the flag we specify to create a volume mapping. Specify the volume name which you have created on your local VM or on your host machine, that is volume1. Then colon, specify which location inside the Docker container you want to map to your volume. Think volume like a shared storage or a shared drive. Anyone makes the changes in anywhere, it should sync at both the places. That is what volume mapping is. So take an example. I am mapping /app location inside my container with the volume1 that I have created on my host machine. Now the question is, if the /app directory file system is not present in the container, what will happen? It will not throw an error. It will create the /app directory structure in case it is not present. So let's say I'm using Tomcat image. Let's run it. So now let's do Docker PS. An image got created right now with using this Tomcat, right? Now let's go inside this container. So Docker exec -it container ID and bash. Now you see I'm inside the container. I'm no more on my host VM. So now if I go in the / directory structure, I should see it should have created a folder called apps. Where it is app. See here, we have a folder created with the name app. Let me go inside this app folder. And if I do ls-lrt, you see all these three files which I created in my local volume on the host OS, they are now present inside my Docker container. Let me create two more files here. Touch, ABC, and DEF. Inside the container, I created two more files, ABC and DEF. The default Tomcat directory structure is USR local Tomcat. Just for a general knowledge, okay? Everything is stored in this default directory structure for Tom. So now let me come out of this container, Control P, Control Q, and now let me kill this container. Docker PS, Docker rm-f, and this container ID. So now that container is not present. Those two files which I created inside the container, will they would have been mapped to the volume mapping which I created? So right now I'm in the directory structure. If I do ls-lrt, see those two files are now mapped in my local host or the host VM where I'm running the container. That is the advantage of volume mapping. Even if your container is lost, killed, whatever, data is not lost. One of the things which we should do as an efficient DevOps Docker administrator is whenever you create any type of containers or image, always do volume mapping. Always make sure logs which are being generated inside your container are being copied or mapped to your local machine. Now, I told you just a while back that USR local Tomcats is the default directory structure where Tomcat logs are stored. Now let me create one more container. Docker run -d-p. Now I am specifying volume2, and let's say now I want to keep a backup of the Tomcat logs. So default directory structure is USR local /tomcat/logs. Will this command run or will it fail? I just gave the create use volume 12, but I have not created previously any volume 12. If I run this command and I run the command docker volume ls, if you want to see how many volumes are present in your machine, you see it shows two volumes, docker volume 1 and docker volume 2. By default, if that volume is not created, Docker engine will initialize and will find that volume and will create that volume. So for example, volume 2 was not created by default, it just initialized and created the volume 2. Now comes the second problem, the runtime environment. I have four environment and I want to pass different values to it. Different values to QA environment, different values to dev environment, different values to prod environment. How to do that while doing in the runtime environment? Right now, whenever we are creating volume mapping, it's by default created in the default location, var lib docker. But it is not mandatory that you always use the default directory structure. We can always override the value and define in which directory structure or location we want to create our mount point. This concept we called as bind mounts. That means here I am not going to use the default mount point or default directory structure to create my volume mapping. Instead, I can define my own directory structure to create a mount point. Now, how to do that? Let's see. Let me create a folder, let's say QA. Let me create a folder dev. Let me create a folder prod. Let me create an index.html file, h1 learning docker. Let's save this. Let me copy this index.html file to QA folder. Copy this index.html file to dev. And copy this index.html file to prod. Prod, what is prod? cd qa and ls there, cd dev ls, cd dot dev ls, cd dot prod. We have, let's say, three different index.html. Let's say for three different environments, we create three different folders: root qa, root dev, root prod. Now, every time I want to create a container, I want to map this particular directory structure: root prod for my prod environment, root qa for my qa environment, root dev for my dev environment. So how can I do that? I can simply define my location where I want to create a volume map. So how to do that? Docker run -d -p, let's say port forwarding -volume mapping. So what is the first one? /root/dev. This I am mapping. Let's say I want to use Nginx image. So the Nginx default path is usr share Nginx and I think HTML if I'm not wrong, and then the Nginx image. So what is happening is, if it's I'm using a QA environment, then I'm doing a volume mapping in the directory structure root dev. If I want to create for a QA environment, I will put root QA. If I'm using for root dev, I give root dev. If I'm doing for prod environment, I'll give root prod. That is how I can define the volume mapping for my specific environment. That means I'm passing the value for my runtime environment. That is the beauty of it. So there is no need that I need to use the default location varlib docker only. You can define the location of your choice. That is how we can solve our second problem, which I showed you. No need to create multiple images for different environments. You can define the value in the runtime. So this concept is super helpful mainly with databases. So for example, let's say Saurabh created a database, MySQL database. Generally what happens in databases, when you work for any organization, database password different for the QA environment, different for prod environment, different for dev environment. This is where you can use this thing to the best of the scenario. So let's do one thing. Let's take a database image and try to see it. Let's take a MySQL image. Let's go to Docker Hub and let's try to find the MySQL image. Let's take MySQL. I just want to see some example. We have done some volume mapping. Let me copy this. Here they define user also. So it's a bit more complicated. Let's take an easier one. Let's take this. We clear this. D Control V. Now see what they're doing in this example. Here we are trying to create a MySQL database. Let's not provide some tag value. So now here they're doing a volume mapping. Provide your own location. Which location you want your data volume to be created. Okay, my own data directory. Let's say /root/dev/push, whatever you want. Then you are mapping inside the container varlib MySQL directory. That means you're creating a blind mount. This concept is called as blind mount, where we create our own path, not we use the path given by Docker. And then I'm passing an environment variable in the runtime -e. I'm passing a MySQL root password, whatever password is, and then I'm creating the container using a MySQL image. So that is how we can define our own path, or which we call as blind mount. So whenever you use your own path, not the path defined by Docker, we call it as blind mount. Now, one last concept which I want to discuss with you. There are two ways to create a volume. One is -v, just now we discussed. Another way which is coming in the latest version of Docker is --mount. There are two ways to create a volume, -v or --mount. Both carries the same message. There is no difference. Now I will paste the same command using -v and -mount. I will just copy this line. And if I use volume mapping, this will come like this: -v nginx -vol colon usr share nginx html. Are these two commands look to you same, or is there a difference? Only difference is mount is more verbose. You specify two extra fields called source and destination. Source means the location on the host VM, okay, or your Docker engine, and destination where inside the container you want to map to. Otherwise, technically, both are exactly the same. So in your Docker certification exam, if you see --mount, don't get confused. It is same as -v. It is just a more pervasive, or you can say a better way to do a volume map. Now, another good thing about using --mount is, let's say I want my mount point to be read only. I don't want my mount point to be able to update any data or write any data. Then I can define a flag called read only, which I cannot do with volume map. I can just make it as read only, that only write the data logs. No one can delete the file, or no one can do this thing. That's all I have had for today. Thank you so much.